Bienvenidos, Ushamandid, and welcome Anne Arundel Community College learners from the CTS-130 Section 402 course for the spring 2021 semester. This is the Cisco Networking Academy Introduction to Networks version 7 course curriculum, and in this packet tracer tutorial and solution set, we're going to be taking a look at a custom skills activity. Skills activity number 2 is going to test our knowledge and understanding of how to assess IPv4 addressing and then perform troubleshooting. So let's go ahead and dive in and take a look at the topology as it stands right now. So here is our topology. We have an addressing table here at the top, and you can see we're missing some default gateway information here for PC1 and PC2. So the objectives: take a look at the addressing and default gateways, test connectivity to devices on the same network, and then test connectivity to devices on a different network. And so remember that the router is a layer 3 device. And so the layer 3 device separates broadcast domains, separates subnets, separates what you might think, you could say VLANs, but you could have the same VLAN on both sides here, because again, that's a layer 2 construct. So the router breaks up the broadcast domains, right? It breaks up the subnet. So we have one subnet on the right-hand side, and we have a different subnet on the left-hand side of this router. So we're going to examine IP addressing and default gateway. So step 1, the router address configuration is correct. And so we're going to dive in here to test a few things. And so the first thing we're going to test is part number 2, connectivity on the same network. So let's go ahead and click on the server, and let's see if we are able to ping with the server. And we're going to ping the 192.168.2.1 address. And as you can see, we have connectivity to that address. If I was to take a look at the configuration, you can see that that is the default gateway. Again, the default gateway is a device that the server will use when it realizes that it is not connected to the network to which it is trying to communicate. So, in other words, when the server tries to ping something on the left-hand side of the diagram here, PC1 or PC2, these are not on the same subnet. Therefore, the server knows, because it doesn't have that network in its routing table, that it's going to send that traffic to the default gateway. In other words, think of the default gateway as sort of the last resort. In other words, I have no idea how to get to this network, so I'm just going to throw the traffic to the default gateway, the layer 3 device, in the hopes that it does have a network and that it does know how to reach the network that I'm trying to get to. All right, so that connectivity worked. Now let's test connectivity between PC1 and PC2. And so we'll pull down PC1, and let's go ahead and try to ping 192.168.2.100. And, oh, I'm sorry, I think it should be 1.20. So let's do a Control-C on that. .1.20. And I believe that that is the IP address here of PC2. So let's double check. We can take a look at the config. And so the address here is 192.168.1.20. And I'm pinging, and you can see here from PC1, those pings are timing out. It says, if not, review part 1 again. And so it doesn't appear that we are able to ping. So let's double check. Let's make sure I've got the right IP addresses here. So PC1 is 192.168.1.10, and PC2 is 192.168.1.20. And so it's not working. So what might the problem be? Well, let's check PC1's configuration here, and let's see. Again, remember, this is IP addressing and troubleshooting. And we take a look at PC1, and do we see anything that doesn't look correct here when compared to the addressing table? And you got it. We see that PC1 has an incorrect IPv4 address. It should be 192 PC1.168.1.10. .1.10, not 10.10. So now we've placed PC1 on the correct subnet. Let's come back to the command prompt and let's give that another try. And we can see now that the connectivity works. Again, the connectivity didn't work initially, so we jumped in there and we resolved the issue. Now, when we look at PC1, another way to see the configuration is to say simply ipconfig. So when we take a look at the ipconfig command, we see here, and we would have seen the incorrect IP address, but what we see here is what we just changed, and that is we have the correct address. We have the correct default gateway address. So let's look at PC number 2, and let's see, again, we look here and we see some information, but let's go to the CLI and say ipconfig. And what do we see? Well, we see our IP address. We see the subnet mask, which is correct for a Class C address. It's a 255.255.255.0. And then here we see a default gateway of 1.2. Well, let's check over here. PC1 shows a different value for the default gateway address. It shows 1.1. So the question is, out of these devices that are here, what is our default gateway? Which device would be the default gateway? You've got it. It's going to be the router. Again, that's that layer 3 device. We typically don't say that we have a layer 2 default gateway. The default gateway is inherently, by definition, a layer 3 device, a router. Or it could be a multi-layer switch, which we'll talk more about as we move on here. So again, the router is going to be the default gateway. The question is, which PC has the correct information? Is it 192.168.1.1, which is what PC1 thinks the default gateway is? Or is it 1.2, which is what PC2 thinks it should be? Well, there's an easy way to sort this out. Let's pull the router up and let's see what the router has configured. And we'll get into the router. So we'll go from user exec with the enable command into privilege exec. And I'm going to say show IP interface brief. And we can see here that it's configured for 1.1. However, it's administratively down. Now let's check the router addressing table up here. And you can also see up here, it is 1.1. That is what the address should be. So how do we sort this out? Well, let's get into global config and let's go into interface gigabit Ethernet 00. And you can say G00, you can say GI00, you can say GIG00. You could spell gigabit Ethernet out. So that'll get you into that interface. And we'll say no shut. And as you can see, the interface is now moved into the up state with that green triangle we have here. And that orange dot, that is spanning tree on the switch, kind of doing its thing, going through the listening and the learning state before it transitions into the forwarding state. Now, we haven't talked about optimizations with spanning tree yet. That's going to come at a later time. In fact, I believe that's in the next course. Where we can avoid that orange dot and have it transition to the forwarding state immediately. But we'll leave that conversation to the side for now because now you can see that the interface is up. So what do we need to do? Well, let's check. Can PC1 ping its default gateway? 192.168.1.1. And it can. What about PC2? Now we're going to try to do a ping here, 192.168.1.1. It can, and we don't need to change the default gateway right now because this is on the same subnet. It's in the same VLAN. It's the same broadcast domain, right? So I can ping that address without needing to use the default gateway. But as soon as I try to ping 2.1, and let's actually see the server, I want 2.100. If I try to ping 2.100, what we'll notice is that it's not going to work. And you'll see the request is going to time out, and I've got the wrong default gateway value in there anyway. So let's take care of that here. Let's go to the desktop again. Let's go to our IP configuration, and let's change that to 1.1. And so now we'll come back over here, And let's see, can I ping now? Because now I have the right default gateway value. When PC2 goes to ping server PT on the other side in the other broadcast domain, the other network, the other subnet, it says, hey, I'm not connected to the 192.168.2. I don't have that. Oops, not metstat, sorry about that. I don't have that network in my routing table. And I think you could throw an option on here. It's RN or is it in? I can't remember the option I'm trying to think of, or netstat-a. It's one of these. There we go, netstat-r. Sorry about that. And so this is the routing table for the PC, right? The PC has a list of networks to which it is connected. And it doesn't have the network 192.168.2 in here. And so what does it do? Well, it does have an entry for the default gateway. And it says I go out that interface, which is my NIC card to get there. That's how I'm going to get there. And that's where I send all the traffic to which I don't have a network statement here in my netstat routing table for. So it doesn't know about the 192.168.2, but that's okay. It doesn't have to. It sends the traffic to the default gateway. That Hail Mary, that last chance, right, to get rid of that traffic so that it does get to where it's supposed to be going. So now we know the default gateway here for PC1 and PC2 is 192.168.1.1. So again, we're testing connectivity between the remote network devices, PC1 and the server. So can we ping to the server now? So let's ping the 192.168.2.100, and it works like a champ. So here were some commands that we could have run. And it said, make any necessary connections to test the connectivity. Now, again, the reason connectivity from PC1 would have failed over here to the server was that this interface on the router was shut down. And we took care of that. For PC2, it had a bogus default gateway and the interface would have been shut down here, but we brought the interface up, which then led us to that default gateway value that was incorrect. But we got that sorted out. And so now all of that connectivity is working. So now we want to test connectivity between the server and switch 1. So we'll pull up the server. Let's go to our command prompt. And the address that we have here is 192.168.1. Whoops, and let's get the right IP typed in there without that typo, 192.168.1.2. And again, if I come up to the addressing table, you can see the switch virtual interface for VLAN 1 for switch 1 is 192.168.1.2. And there's the default gateway value. Now remember, on switches, layer 2 switches, they are not routing traffic. And the default gateway statement on a layer 2 switch is just like the PC when we go to the configuration and we put in a default gateway. So for traffic generated by the PC, for a network that it doesn't know about, it uses the default gateway. And the same is true of the switches, the layer 2 switches. It's treated when we generate traffic on the switch, when I'm trying to ping the 192.168.2.100, this is traffic being generated by the switch, not traffic that is transiting through the switch. And so for this traffic the switch is generating, just like traffic the PC is generating, we need a default gateway if that traffic is going to be going to a different subnet, a different broadcast domain, a different network. And how do we do that? Well, we go into global config and we say IP default gateway, and then we put in the default gateway statement. So now when this switch is generating traffic that's going to a network that the switch is not configured for and doesn't know about, just like the PCs that are in this network on the left-hand side, what is it going to do? It's simply going to send the traffic to the default gateway, and we have success. And let's take a look at switch number 2, because switch number 2 had an IP. So if I try to ping the 192.168.2. And let's double check that IP, 2.2, from PC2, is it going to work? And the answer is no. The request is going to time out, because even though PC2 has the correct default gateway statement, and you can see here that it must be configured on switch 2. That IP default gateway has to be configured here on switch 2. So initially it timed out. I thought we might have to go in here and configure it, that would be another configuration error we would have to address. However, it appears it's working, and we can easily check that out by logging into switch number 2 and taking a look at the running config, and specifically not the entire running config. I can say show run and then include only the lines that have default on them. And there you have it. If that command was not on the switch, so let me say no IP, default gateway 192.168.2.1, and let's 192.168.2.1. If that statement was not on switch 2, and PC2 or PC1 or switch 1 tried to ping switch 2, it would not work. Let's pull switch 1 up. Can I ping 192.168.2.2? And you can see it's not going to work. And the problem isn't with the devices on this side of the network. These devices here, they all have their default gateway statement. And they know that to ping switch 2, they're going to send their traffic where? To the default gateway that's configured. It's all going to come to the router here. And the router's going to say, yeah, I know how to get to that network. And it's going to say, I'm connected to that network, and I know where that device is at, and it sends it to this device. The problem is here. When switch 2 receives those ICMP echo request packets, the ping packets, and it says, okay, great, I see the source IP address in those ICMP packets. And it's the addresses over here in this network, because they're the ones generating these pings. Now, switch 2 says, I'm going to try to reply to those ICMP pings. And so what does it do? It says, well, I don't know about the network that they're on, and I don't have a default gateway configured. The traffic is dead right there at switch number 2 when it goes to reply. So the pings are getting here. However, switch 2 is incapable of getting the ICMP echo request packets back to where they need to go because there's no default gateway configured. So let's go ahead and sort that out. Let's drop that statement back in here. And, whoops, sorry, I went the wrong way there. Let's put that IP default gateway statement back in there. And now let's come to switch 1 and let's try to ping switch 2. And it works because now switch 2 knows how to get back to the network that it doesn't have any information for. And that was actually 2.100. We wanted 2.2. So switch 2 now knows what to do with traffic that it doesn't have a network to which it's directly connected. It sends it to its default gateway, that Hail Mary pass at the end of the game saying, hey, we've got no other option here. Let's just throw it to the default gateway. Let the default gateway deal with it. And now everything is going to work. And so report partial network documentation, right? On the PCs, you could simply come on here and say ipconfig and ipconfig/all. You're going to get all the information you need. There's your MAC address. Here's all the IP address information. And we would do that for the devices it's asking you to do that for. The server and the PCs. And then using privilege exec mode, right, which is the enable command gets me into privilege exec mode, we would say show interface on the router. So we'll come in here and we'll go from user exec to privilege exec. We say show interface. And then I would find the gigabit Ethernet 00 interface. And then there's that burned in MAC address. And I would come down here to the other interface on the router and grab that information. And then you would provide that documentation stating here are the physical layer 2 MAC address addresses for the devices that are in question here. All right, well, we are now at 100%. We've got end-to-end reachability on both sides of the router for both broadcast domains, which the router separates broadcast domains. It separates networks, and that is what we're focusing on here. All right, well, that is going to do it for this packet tracer activity, skills number 2, where we took a look at IPv4 addressing and did some troubleshooting. All right, thanks so much for watching. Let me know if you've got any questions, and I hope to see you guys in the next video.